Okay, watch it, see if it stays. Okay, we're gonna explore now, finishing the video, we're gonna explore the technology readiness. I was just digging some of my papers and I find according to technology readiness level, are NASA generated and used extensively by the Department of Defense. This is the American nomenclature. I think let me see if it comes up all right there. Don't move it, please. Just keep it where it was. And it says, okay, basic is level 1, 2, 3. Basic principles observed, concept, analytical experimentation, experimental critical function. Then apply the components and breadboard validation. Components are breadboard validation in relevant environments. It's number 5. System, subsystem, model, or prototype demonstration in a relevant environment. Number 6. And system prototype demonstration in operational environment. I think we're at that level now. So if we go by this chart, which, like again, I said is NASA stuff, and DoD uses this nomenclature, we're about 6 or 7. I don't know exactly in Europe which, how do you go by, if we can extrapolate directly to the European standards you use for technology, or how do you really evaluate technology readiness. Anyway, what I could say is I would like to divide the wire cutter in in 3 segments, and for example, we'll keep the basic, let's say the blade, the piston, the footing, the concept of the piston, the charge into the piston with the kinetic energy blade and hitting the footing, all this embodied into the aluminum housing, which with the guides, you know, we know the guides concept. I think this is I could say it's a very, well, I don't know if mature is the right word, but I would say this is a concept that will stay. I would like to have this as a constant concept. I would like to develop not a single shot like I said earlier in the other video, but a multi-firing device that we can fire at least 3 or 4 charges. I don't think developing that will be much of a problem, although we don't have one, but we can readily absorb what is known in revolvers and guns technology and adapt it for our situation. So that is not, we don't need no breakthrough in that respect to make a multi-firing head system. And the rest will be applied. Oh, okay, this is what I wanted to make mention. In my concept, the firing system, which is the trigger, the firing pin, and the ignition of the charges, which is regular military Verdun primers, I like to keep that at 100% mechanical. So that gives us the reliability of such systems. If we want more redundancy, we could have 2 firing pins in 2 primers at once into a single charge, or 2 firing pins into 2 charges completely, and both combining into the piston. I don't know, that will be a criteria to be determined later in the design, but like I said, the only electronics that I would like to incorporate, and I could be wrong, you are the experts in these fields, and you know what it takes to do things that work. I know a little bit, but I would like to stay away as much as possible from the electronics. Although the electronics will be needed in the control, more than control, it will be because the firing device is control. In the indication, you know, and the monitoring of the status of the system. So I will only use electronics for create an indicator that will go in the panel, and I will have about 3 lights, or maybe 4, and they will say armed, let's say armed, ready, or armed, airborne, ready, disarm, ground, and another light that in the event the unit is used, it will see unit cartridges spent and return for certificate, return to service. And the electronic part I will incorporate will be a locking device that will disable the triggering mechanism. When the aircraft, when the helicopter is on the ground, we'll have a sensor on the foot, and the little servo motor will possibly lock the triggering device, creating a safe condition when the helicopter is on the ground. Helicopters need to be washed. There's people around. You know, we don't need this cutting people's fingers or anything. So we need a ground safe condition. Then we have an airborne ready when the locking goes away and it's ready to fire. And an indication of another malfunction, like I don't know, the event of well, if it's used up, if the cartridge is spent, of course you gotta indicate the system is not active. So that will be the only parts in which I will incorporate electronics. That will have to be the device and implement it according to, you know, today's technologies on panel indications. So it could be blend seamless with the MFVs, or it could be a standalone unit on the panel. For retrofit applications, which I believe this unit will qualify very, very well to do retrofits, we'll probably use a standalone indication. And the newer models, you want a seamless, you know, blend it in with the multifunction displays of the rest of the equipment. That will be another option too. So I think that will be where the readiness of the systems may be right now. Again, like I said, you are the experts, and you will know exactly where all this falls at, and how long. As far as certification, that's the other part. I know what it takes to certify a new device or an STC, that kind of a systems. Certifying, getting a certification with this type of thing, I don't know. It will be an accessory. How is the European authority oversees this type of? I have no idea. You will perhaps tell me better. The FAA, it's very bureaucratic. You know, it has to go through everything. They want to see it all the way to the molecular level explanation. Well, we'll give them a molecular level explanation because there is one, and it's very clear and concise. So, Monsieur Favenec, sorry. This is what I have to say for now, and I hope to hear from you soon, and hope you like my presentation.